We are focusing in now on Unit 6, Part 2, which is dealing with surface area and nets. I know when we finished Unit 6, Part 1, which was area and volume, we took a little break before milestones so that we could really focus on statistics, mean, median, mode, that type of thing, because I knew there'd be a lot of questions on milestones, most likely about that. But now we are getting back into our regular lessons. So we're going with Unit 6, Part 2. We will have a summative on this. I don't have the date yet. I promise I will let you know very soon. So when we are talking about nets and surface area, it's really important that we understand the proper names for certain shapes. So today we're going to focus on prisms versus pyramids. And there are a few very easy ways to tell the difference between prisms, which we see over here, and pyramids. So let's start talking with our prisms. Probably the most common prism that we see all the time is this right here. It's just called a rectangular prism. Pretty obvious why it's called that. This is a shape you see all the time in your house. This would be like a cereal box, a box of macaroni and cheese, anything along those lines, a gift box, okay? And when you think about this right here, it has a front. Well, if it has a front, it also has a matching back, okay? It has a side. Whoops, you can't really see that, I'm sorry. Try that again. It has a side right there, hopefully you can see that, and the other side would be on this side, and again, those are matching. It also has a top and a matching bottom, right? So that's an important characteristic, actually, of all prisms. It has a top and a matching bottom. We refer to these as being the bases. So if you look at this shape right next to it, that's a cylinder. This would be like a can of soup, a canister maybe of oatmeal. It has a top right here, and it has, we don't see it all, but right there it would have that matching bottom. Those are the two bases. All of these shapes, again, here are prisms because they have a top and a parallel or matching bottom. For example, right here, we have a triangular prism. Its top, if I were to turn it up and have it sitting, is a triangle, and its bottom is a triangle. Again, the two bases. Now, one of the other things that I have written up here, whoops, as a characteristic for all prisms is that all the faces, I'm not talking the tops and the bottoms, but all the other parts, all the other sides are rectangles. Pretty easy to tell that on a rectangular prism. If I were to unfold this, it would be made of 6 different rectangles. Same thing with our cube, right? All rectangles are all squares. Our triangular prism, the base are triangles, but all the other parts are rectangles. You might say, well, I don't quite see that. Same thing here with the cylinder. You say, well, the top and bottom are circles, but how is the base of it, or how is the, the other part of it a rectangle? Let me show you. Here's a triangular prism, right? We obviously see the two triangles. Those are the bases, but all the other pieces are rectangles if I were to unfold this. Same thing with a cylinder. The top and the bottom are obviously circles, but if I were to unwrap it, this yellow section right here is a large rectangle. So again, with a prism, all the faces, except for the top and bottom, are rectangles. Now it's possible the top and bottom might be rectangles, like with our rectangular prism. But three characteristics of prism: has a top and a matching bottom, which are the two bases, and all the faces are rectangles. Let's contrast that over here with a prism. With a pyramid. Okay, if you look at all of these shapes right here, hopefully something popped out at you. They all come to a point. A point, and like a bright red Rudolph nose on it, right? Notice they all come to one point. There's no other point. They only have one base that's down here on the bottom. So example, right here is our base of that shape. Again, we have a base right here. There's no matching top because the top is a what? It's a point, all right? Here's the base of this. Does the top of it match? No, the top is a point. All right, and same with all the other shapes. So they come to a point, there's only one base, and all of the faces, in other words, all the faces are triangles, okay? Now, you may say, wait a second, you said it comes to a point, but it looks like over here on a triangular prism that comes to a point. Remember, it does not come to a point, to one point, whereas our pyramid is coming to one single point. All right, important to remember that. So, take a look, if you will, at the three characteristics of prism, top and bottom that match. Those are your two bases. All faces are rectangles. Pyramids comes to a point. Only one base down here at the bottom, and all the faces are triangles. All right, what you're gonna do is do some practice with this. I have a worksheet that you can review over this. You're gonna take a formative check, and I also have a matching game that you can play on Google Slides. All right, hopefully this is a pretty simple introduction to you guys for surface area nets that we're getting into, and I'll see you next week.